Hey, Calculus kids, this is Dr. Callahan for week 5 Friday. Congratulations, you guys made it to the end of the week. So go ahead and pause the video and answer the following questions for your warm-up blog. All right, let's go ahead and create the assignment for today. Friday for Calculus AB Semester 2. And our topic of discussion is going to be on complex integration of natural logs. All right, so the two different links that you're going to need for today is going to be one for the YouTube channel, the other one for the Google Doc if you need it. Make sure you check in with me by second period, the end of second period, which is 9:41 a.m. And let's go ahead and just assign this. This is due by 3 p.m. the day that it is assigned, so Friday. All right, cool. Let's go ahead and just get this started then. All right, so take a look at the answer for your warm-up. Looking at this blue circle, that's like death. All right, so here's your answer right there in yellow. We actually went over this one in class as well, so hopefully you remember this from yesterday's video. Actually, you know what? Yesterday's video, we did the other one. I actually went over this in person in class with direct instruction. So if you're looking at the Thursday's video, I actually went over the other example from that guided note. All right, so for today, I'm going to talk about the different type of strategies when it comes to integration, and there are different methods that we talked about. First one is just the basic rule of integration, like, you add the 1 for the exponent, whatever you get here, you divide it by that exponent, and then you just put plus c. Second one is using trig functions for integration. Third one we talked a lot about is using u substitution. Fourth one is changing your integration in form of a fraction. So that way you can utilize the 1 over u, which gives you ln u plus c. The fifth strategy was integration using long division. And then with long division, keep in mind that this only works if you have, like, let's say, something on top that is exponent bigger than the denominator. So that's when it generally works. And then, of course, 6-1 is integration using completing the square, which we have not talked about yet, but we are getting to that. We're getting to there. All right, you guys. So let's take a look at our notes for today. So here we go. This is your first page. We're going to go over 5 different examples today when it comes to this. Then, of course, you guys have your second page. So these are some of the integrations from your textbook. You don't have a textbook this year, but these are some of the questions that's from there. And then, of course, if you need some assistance, you can access a video from this link, which will go over all of these questions in greater detail. Okay, so with that said, let's go ahead and just get started. So turn over to this page. All right, let's go ahead and take a look at the following. So what I would like you guys to do is maybe pause the video and then go ahead and try these 5 examples on your own. The answers are given to you right there in the little red boxes. And then any of the ones that you don't know, we'll go over it in this video. So pause the video and try some on your own. Okay, I hope you tried it because I'm moving on. All right, let's take a look at the first example. So for the first example, notice that the numerator here is a 1 and it's smaller than the power of the denominator. So this is like a classical traditional u sub problem. So I'm just going to say let u be x squared plus 1. Du is 2x dx. Dx is equal to du over 2x. And this works so perfectly because I know directly it just cancels. So I know this is going to cancel with this one, and then I'm left with 1 over u du. Okay, so that's just going to be ln u, which is x squared plus 1 plus c. And I hope you realize that after practicing with us a while, you can pretty much just kind of like skip a lot of the other unnecessary steps because visually you can see where you're going, and it will save you some time on the AP exam. Let's see, second example. So with this one, it's another classic one. So you have an x times ln x. So let's say let u be ln x, okay? I mean, you could technically say, well, let's let x or let u be x, but then the derivative of x is just 1, and how are you going to give her the ln x? On the other hand, if you're like, okay, let's let u be x times ln x, well, then you have to do the product rule, which is going to make this really, really crazy, and it's going to be hard to like cancel out directly, you know? So you can try it, and if you were to try it, f will be x, f prime is 1, g is ln x, g prime is 1 over x. So then your product rule is f prime times g, so that's ln x, plus f times g prime, which is 1. And as you can see here, if I were to go ahead and solve for dx, there's no way you can cancel the ln x plus 1 with the x ln x here. So that's probably not something you want to go down in that route. But it's always nice to kind of like, you know, try it so that way you can see where it leads. So that way you can make better choices in picking what you want you to be in the future. So then your du is 1 over x dx. So your dx is equal to, multiplied by x on both sides, x times du. Yes, okay. So then I'm going to have my integral 1 over x. We're changing the ln x to a u, changing the dx to a x du. And that's perfect because guess what? X cancels and you have the integral 1 over u du, which is ln u. And remember ln u, u is ln x plus c. All right, let's take a look at example 3. So for example 3, you can say, okay, let's just go ahead and do u substitution. So if you do u equals the denominator x squared plus 1, du is 2x dx, and dx equals du over 2x. So you're like, how am I going to cancel the x squared plus x plus 1 with the 2x on the bottom? That's not going to work. So let's cross that out. So then you can proceed and say, okay, let u be x squared plus x plus 1, but then your du is going to give you a 2x plus 1 dx. That's not going to work either because how are you going to cancel the 2x plus 1 with the x squared plus 1? So we went ahead and tried both methods, and we've kind of exhausted our u sub at this point. So right now what it tells me is that I have to go ahead and rewrite this polynomial or this function before I do anything. And the only way I can see that I can do this is if I actually split the fraction. So I have the integral of x over x squared plus 1. And notice how I only took the middle one because I know if I let u be x squared, I know du is 2x. So that x with a 2x will cancel with that. So that's kind of my strategy. So then what's left behind? X squared plus 1, integral of x squared plus 1 over x squared plus 1. And look at that, because what ends up happening here is that it just cancels off to 1. And you could do the integral of 1, right? That's pretty simple. So what you want to do here first is integral of 1 is just going to give you a x. So this one is already done. But with this one, you're going to do a u sub. So let u be x squared plus 1. Du is 2x dx. and dx is equal to du over 2x. So integral x over u, sorry, I forgot the dx right there. Replace the dx with a du over 2x. And look at this over here. Your x and x cancels. So then I have the integral with a 1/2 on the outside, 1 over u du. Okay, so then what is that going to be? It's just 1/2 ln u. So I'm going to move this x over in the way. U is x squared plus 1 plus your x plus c. And that is your answer. I know that was kind of, a refined example there. I really like that one. Okay, now let's talk a little bit about integration with trig derivatives. Now you have all the trig rules right over here that you will have to memorize, unfortunately. And I hope you guys are pacing yourself when it comes to this, because you don't want to memorize all of this like in April, like a month before the actual exam, because I'm telling you right now, it's not going to be a pretty picture if you're waiting to the last minute. And actually, maybe I will have you guys practice making flashcards in class with this. I think that'll be a good idea as well. So that way you guys have that. So, and before I lose that idea, I want to make sure I get to it. So sorry, I'm gonna just give you a second. Let me just go ahead and do this. All right, so just so you know what I'm doing, I'm actually getting over here to the flashcards, and I don't need you guys to go on Quizlet for this. Instead, what I'm going to do is you can go back to week 5 Thursday, and I believe on that note, we actually went over derivatives and integral formulas, and I have them compared side by side. So you can use that in your guided notes and then make the flashcards at home, because I don't want you guys kind of wait to the last minute. It's extremely overwhelming to memorize all of this, and I completely understand it. I took calculus in high school as well, and to get that passing 5, it was a lot of work. And if you're able to pass the test the first time, it's not easy, you guys. It's a lot of work, and I applaud you for taking this when you guys are so young, and this is extremely difficult. I totally understand. So I'm just gonna try to maybe take this and copy it over from your notes. So it's the last page of week 5 Thursday's notes. And here we go. Copy, close that. Okay, so here we go. And I want to make this a little bit bigger. Whoops, don't want to open that. Okay, so these are your differentiation ones, and here are your integral ones. And I'm just gonna go and type in this from you have this in your week 5 Thursdays notes. Please refer to that section. All right, sorry for the little detour, but I really felt like I need to get that done so that way I don't forget it. So let's go back to this then. For 4a, I have the trig integral rules right above that, so that way you guys can kind of see the, figure out how you would like to proceed with it. So I have an integral of tangent x dx. Now, I don't have one here that you can just automatically do that, because if you look at this over here, you do have like the integral tangent x dx, which is equal to negative ln cosine u plus c. And if you're like, how did that happen? Here is the way that it is done. Like, obviously they had a method of doing this. So this is the kind of the history behind how you get from here to here. Okay, so you know that you can rewrite tangent x as in sine x over cosine x dx. And then what you're going to do is you're just going to go ahead and use a u substitution. So let u be cosine x dx. Derivative of cosine is a negative sine x dx. So then dx equals du over negative sine x, which is perfect because I know I can cancel that. So if I rewrite this, I have a sine x over u. Replace your dx, which is a du over negative sine x. Cross that part out, integral 1 over u, negative du. Okay, so then here, what's going to end up happening is you are going to have a negative ln u, and remember your u is going to be a cosine x plus c. And that's exactly how they got that right there. So this is the answer, and this is the reason behind how this formula comes to be. Okay, so next thing I'm going to talk about is cotangent. So how do you get from cotangent u to ln sine u? So go ahead and pause the video and maybe try this on your own to rewrite this and see where you get to. All right, so another way of writing cotangent. Remember, this is just a reversal of tangent, is cosine x over sine x dx. So with this one, let's say let u equals sine x dx. Du is going to be a cosine x dx. So then dx equals du over cosine x. Okay, so then next, integral of cosine x over u, replace that dx with a du over cosine x. I can cancel that. So integral of 1 over u du, which is the integral of that is ln u, and u is sine x plus c. And that's exactly, wait, hold on a second. I think with this one, I made a typo. It should not be a negative ln, it should be a positive ln. So let me just go back to this one. Yeah, it is. It's a positive. Sorry about that, guys. It is totally a positive. I'm like, I'm pretty sure they didn't make a mistake on a textbook, and it is. It's ln sine u plus c, positive, not a negative. So I'm just gonna go back to this and modify that. So that way you guys know that there is a typo, and yeah, I'm glad I caught that. So let me just go ahead and insert a text right here, and I'm just gonna put positive ln. Yeah, that sometimes does happen, and okay, let's go ahead and change it, make that a little bit smaller. All right. All right, so then let's go on to the next one. This will be your last example, which is example 5, and we're going to do a long division. You know that because the numerator is greater than the denominator. So let's go ahead and rewrite this. I'm going to go ahead and rewrite it like so. My numerator is going to be x cubed plus 0x squared plus 6x minus 20. My divisor is x plus 5. So x times x squared, and remember, you're going to multiply this through, is x cubed plus 5x squared. If I go ahead and subtract this part cancels. 0 minus 5x squared is a negative 5x squared. Bring down the 6x, okay? Then I'm going to go minus 5x, distribute that in, negative 5x squared minus 25x. Make sure you distribute the negative. That makes it a positive, which cancels. 6 minus 25 is a plus 25. So that's going to be a 31x. Bring down that negative 20. Minus 31, distribute that in. You get a negative 31x, or I'm sorry, positive 31x. There we go. And 5 times 31 is going to give me, that's going to be a 5, 15, 155. Sorry, I'm just checking my math to make sure I'm doing everything correctly. -5, that's correct. -25, yep. So far looks good. I don't think I'm making any mistakes. Although if I am, I apologize. It's not done intentionally. And so if I subtract this, that part cancels. This becomes a negative. So that's a negative 175. And that's my remainder. Okay, so then I have my integral, which is going to be my answer, and that's my quotient, x squared minus 5x plus 31, plus the remainder, which is negative 175 over the divisor, x plus 5. Okay, so I'm going to go ahead and just integrate these separately. Okay, and integral of the first one is 2 plus 1, which is a 3, divided by 3. So my answer is x cubed over 3. Integral of the negative 5x is 1 plus 1, which is a 2, divided by 2, which is a 5 over 2x squared. Integral of 31 is 31x. And then with this last one, we're going to do a u substitution. Let u be x plus 5. So then du equals just 1 dx. And so dx equals du. So then I'm going to do the integral. I'm going to move that 175 on the outside. 1 over u du, which is going to give you a minus 175 ln, and you're going to replace the ln with x plus 5 plus c. Sorry, I have that right on the slide. And this is your answer. All right, you guys, as always, have a wonderful week. Have a good Super Bowl Sunday, and I'll see you guys next time. Take care.